Hi folks, we are on the Unit 3, Day 8, and this is the second video. Here we're going to get into some examples of using matrices to solve a system of equations with 3 equations and 3 unknowns. And as you'll see here, this ends up being a much better application of these matrices. If we're using matrices, like I said in the last video, for just 2 equations and 2 unknowns, it's really kind of overkill and it's more work than you need, and it's overly complicated for a pretty simple solution. However, if you were trying to solve 3 equations and 3 unknowns, or even kind of more difficult of a question with 4 equations and 4 unknowns, which we won't see in this course, but we may see later, you may see later in university, then matrices are really kind of much better for 3 equations, and almost the only thing that you would be reasonably able to use to track your work if you got into 4 or 5 unknowns. So here we've got 3 variables, x, y, and z, and we're going to solve this system of equations. You may notice that these look sort of like the Cartesian equation of a plane, which they are, and we're going to apply this skill to solving for intersections of 3 planes in the next lesson. So if we take this, I'm going to just transcribe the coefficients only in the same way that we did with the 2 by 2, and set up my matrix. Remember that the vertical line here is where the equal sign would be in your question. Now I'm going to kind of briefly go through the steps that we want to go through to get to that identity matrix. So here we've got the first step. You're going to want to get a 1 in that top left corner. So that's the first thing you need to do. If you don't get a 1 there first, it's going to be harder to get the next things. And if you do this out of order, if you say, hey, I see step 3, I can get a 1 in that middle spot, you might get that 1, but when you go back to try and get the 1s or 0s before, it may mess up the 1 that you found there. So this order is really important. The first step is to get a 1 in the top left hand corner. The next step is to get 0s in the rest of that row. So this is similar to what we did in the 2 by 2, and it can be extended into bigger matrices as well. Once you have this row all correct, and you can see I've just put a number sign for any old numbers that are here, kind of whatever happens. Then you want to get a 1 in the next column over in the spot where you want that 1. That's the middle. Once you get that, the next thing you're going to focus on is in step 4 is to get 0s in the rest of that middle column. The 5th step is going to be get a 1 in the bottom right, and then 0s in the rest of the right-hand column. And once you get there, you've got 1x plus 0y plus 0z equals this number, 0x plus 1y plus 0z equals this number, and 0x plus 0y plus 1z equals that number. So you've got x equals that, and y equals that, and z equals that. So you've got your solution. So that's the order that we're going to go through. You can, especially once you get kind of used to this, the first problem I'm going to work through and go very slowly step by step and look mostly at these in order. But you can do these 2 steps together. You just get the 1 here, and then in the same step of your solution, you could also get 0s. So you can combine, and then similarly with 3 and 4, you can combine those 2. And 5 and 6. So you may only, especially once you get good at this, you may only do this in 3 steps. 1 step of operations for the first column, 1 for the middle column, and 1 for the last. So going back to our question here. We've got example number 2 in this lesson. And the first thing we wanted to do, remember, was to get a 1 in the top left corner. And this is a little bit easier. We've already got that 1 there. If you had these written in a different order and you had the second or third equation that had a 1 with the x, I would swap the order of that right before I put it into the matrix. And I would like automatically kind of switch those two around just to save myself a step of work there. But we don't have to do step 1 here because that's done for us already. Now we're going to go on to step 2, which is to zero out those two elements in that left-hand column. So to get rid of this 2, to make that a 0, I'm always going to be working with the one that's finished. I've got a 1, and that's an easier thing to work with. So I'm going to take this 2 and subtract 2 of the 1s. So row 2 will be equal to row 2 minus 2 row 1s. So whatever is here minus 2 of the 1 above it. And then for row 3, I have a -3. I'm going to do row 3 equals the old row 3 plus 3 row 1. So I'm always using that one that I've already kind of created as a 0 or a 1 to zero those out. So I'm not touching row 1. I'm just going to copy that down like that. Now I'm going to take row 2 and subtract 2 times row 1. So 2 minus 2 times 1 is 0. -5 minus 2 times -3. And again, be so careful with these minus and negatives, especially if you get into somewhere you have fractions. It's not a bad idea necessarily to use your calculator even. And 1 minus 2 times -2s, that's +4. 1 plus 4 is 5. And 3 minus 2 times -9. 3 plus 18 is 21. Now I'm going to take row 3 and add 3 times row 1. So I have -3 plus 3 times 1 is 0. 6 plus 3 times -3 is -3. So that's 6 plus -9. 2 plus 3 times -2 is -4. And 8 plus 3 times -9. So that's 3 times -9 is -27. And 8 minus 27 is -19. So that's my second step. The third step was to get this one as a 1. And that's worked out pretty well. It just kind of by luck, we ended up with a 1 there. So we don't need to do anything for step 3. If by chance you got to this step and you had, say, row 3 had a 1 in that spot and this had something else, you can swap those rows around to save yourself, especially if you may end up with fractions trying to divide out something to get that 1. But here we're pretty lucky. We can skip step 3 because it's already as a 1. So I'm going to go to step 4, which is to get zeros in the rest of that column. So here, this -3, I have to add 3 1s to make that a 0. So row 1 equals row 1 plus 3 row 2s. And it's going to be the same thing here. Row 3 equals row 3 plus 3 row 2s. And we'll go through and add those guys up. So row 2 is going to stay the same. We're not doing anything to that one. Now, you will notice as you go, the calculations get easier because you've got some zeros and ones. So row 1 is row 1 plus 3 times row 2. So 1 plus 3 times 0 is just 1. -3 plus 3 times 1 is 0, which is good. That was our goal. -2 plus 3 times 5 is 13. -9 plus 3 times 21. 3 21s is 63, and a -9 would be 54. And then doing the same, adding 3 row 2s to the third row here. 0 plus 3 times 0 is 0. -3 plus 3 times 1 is 0, which was our whole point here. Negative 4 plus 3 times 5 is 11. And negative 19 plus 3 times 21, that's again 63. And negative 19 would give us 44. So this is my step 4. Now I have to do step 5 and step 6. So step 5, remember, was to get a 1 in that bottom right-hand corner. So I'm going to do step 5 separately from where I, once I get kind of the hang of this, I would normally do step 5 and 6 together personally, but you never have to. So here, the easiest way to get a 1 there, we can multiply or divide by something, and this is going to work actually pretty nicely. I'm going to divide row 3 by 11. So here I'll just put row 3 equals row 3 divided by 11. So that's the only change I'm going to make here. The third row, I'm dividing an 11 out of each term, so 0, 0, 1, and 4. And I'm not going to change the other ones. Like I said, I normally, and if you're comfortable, you can totally kind of do this all together. For the next example, that's 21, not 12. For the next example, I will combine some steps to show you how that goes. So the last step is to zero out the rest of that third column. So here for row 1, I need to get a 0 in that spot. So I have to take away 13 of these to get rid of that 13 to make it a 0. So row 1 equals row 1 minus 13 row 3s. And row 2 equals row 2 minus 5 row 3s, because I have to get rid of that 5. Row 3 is not changing, it is done. And we can see that my Z will equal 4. So row 1 is the old row 1 minus 13 of the row 3s. So 1 minus 13 times 0 is 1. 0 minus 13 times 0 is 0. 13 minus 13 times 1 is 0. You see how the calculations do get a bit easier in the last steps. And then 54 minus 13 times 4. So 13 times 4 is 52, so that ends up just being 2. And then we'll subtract these ones. The middle row minus 5 times the bottom row. 0 minus 5 times 0 is 0. 1 minus 5 times 0 is 1. 5 minus 5 times 1 is 0. 21 minus 5 times 4 is going to be 1. So that's my solution. So this gives me a solution of x equals 2, y equals 1, and z equals 4. So that's the solution to this system. I'm going to do one more example where we're going to work through. And in this one, I will kind of combine together some of the matrix operations into multiple steps. This one does get a little bit messier, but it's a good example of where you can kind of combine steps, and a good reminder of how you have to be really quite careful when you're doing these calculations. So the first thing is, if I'm looking at these when I'm putting them into the matrix, I don't want to have to try and get a 1 there. Because to get a 1 there, I'm going to have to divide everything by 3. And I don't want like negative 19 over 3 right off the bat. That's going to be really messy, especially when I see this guy down here. This one has a coefficient of negative 1. So I'm actually going to swap those around and just put them, because the order here is arbitrary. It's just 3 equations. It doesn't matter what order you write them in. I'm just going to do... when I'm putting these in the matrix, just swap those into the opposite order. So here I'm going to do negative 1, 5, negative 2, 27, and 4, negative 5, 3, negative 38, and 3, negative 1, 2, negative 19. So as you can see right off the bat, I'm just kind of planning a bit ahead for that first one. So here I'm going to do, sorry, bumped my camera there. I'm going to do step 1 and 2 together in one step. So the first thing is to get, step 1 is to get a 1 in that column. So row 1 equals row 1 times negative 1. So I'm just going to multiply through by a negative. And then swap the sign of everything in there. Now, instead of filling these in and keeping them the same, I'm going to save myself some time and just say, well, I know now I've got this. I can use this to zero these ones out. And here the order is kind of important because I've already done this operation to row 1. Now if I down here reference row 1, I'm going to be using these new coefficients that have already been adjusted. So I'm going to say that row 2 is row 2 minus 4 times row 1. But when I do the minus 4 times row 1, I'm going to use these ones up here. It is a little bit of a time saver, but if you'd rather do it in all 6 steps by themselves, that's totally fine as well. So here I get 4 minus 4 times 1 is 0. Negative 5 minus 4 times negative 5. So again, you have to be really super careful here. That's 15. 3 minus 4 times 2 is negative 5. So just super careful with your calculations and your negative signs. Negative 38 minus 4 times negative 27. So you've got like a double negative there. If you want to plug these in on a calculator, I will say I made a mistake running through this in the video the first time, so I actually have them all written down. Going through and doing the row 3. So row 3 is equal to the old row 3 minus 3 times the new row 1. So here I've got 3 minus 3 times 1 is 0. Negative 1 minus 3 times negative 5 is 14. And 2 minus 3 times 2 is negative 4. And negative 19 minus 3 times negative 27. So double negative there gives me 62 up in that spot. Okay, my next step is going to get me a little bit of a mess here, because if you're looking at these, there's no good way to get a 1 in that spot. This is going to come up with some fractions. I couldn't even swap this around. Like if this one could divide out and get a 1 in there easily, I would switch equation 2 and 3, but I think we're just going to have to go with it. And we're going to take row 2 and divide it by 15. So row 2 is row 2 divided by 15, which is not ideal, but we are just going to not be afraid of fractions. So when I divide that, I get a 0, a 1, negative 1/3, and I believe 14 over 3. And now I'm going to also do row 1 and row 2 to get the zeros there. Now, when I'm doing row 1, it's going to be the old row 1 plus, and I've got a negative 5, so I have to add 5 of these 1s. So plus 5 row 2s. So here I have 1 plus 5 times 0 is 1. Negative 5 plus 5 times 1 is 0. And this is where maybe you want to pull out your calculator, especially with some of the bigger numbers here. 2 plus 5 times negative 1/3 is positive 1/3. That's not so bad. This one's maybe bigger than what you want to do in your head. Negative 27 plus 5 times 14 over 3 is negative 11 over 3. And like I said, I've got these written down. I had to do them first instead of calculating on the fly here. And then for row 3, I want to zero out that 14. So I'm going to have to subtract 14 times row 2. So it's the old row 3 minus 14 row 2. So here, 0 minus 14 times 0 is 0. 14 minus 14 times 1 is 0. Negative 4 minus 14 times negative 1/3. That's going to get messy, but it's 2/3. And then 62 minus 14 times 14/3. That ends up as negative 10/3. So sometimes when you get like such a really bad, messy situation here, people can kind of start to panic, but it's not necessarily going to be bad in the end. You're not necessarily going to end up with some terrible numbers, as you'll see in a minute. And I think you can probably start to see that we could solve this equation for z pretty easily. So that was step 3 there, and step 4 to get the zeros all together. Now I'm going to do step 5 and step 6 in one step. So step 5 is going to be getting a 1 in the bottom right. So I'm going to divide row 3 by 2/3. So row 3 equals row 3 divided by 2/3. And that actually makes things a whole lot better because I get 0, 0, 1, and then negative 5. So that negative 10/3 divided by 2/3. Much nicer numbers to work with. Now I'm just going to have to zero out that 1/3 and negative 1/3. So for row 1, that's going to be the old row 1 minus 1/3 of row 3. So minus 1/3 of these guys. So the old row 1, we have a 1 minus 1/3 times 0 is 1. 0 minus 1/3 times 0 is 0. 1/3 minus 1/3 times 1 is 0, which is good. Negative 11/3 minus 1/3, and this is, you have to be careful that you're going to the new numbers here. Minus 1/3 times negative 5 gives you negative 2. And then for row 2, we're going to do something very similar. It's going to be row 2 plus 1/3 times row 3 because we had that negative there. So the middle row here, we've got 0 minus or plus 1/3 of 0, still 0. 1 plus 1/3 of 0 is 1. Negative 1/3 plus 1/3 of 1 is 0. And then this is the messy part, 14/3 plus 1/3 of negative 5 gives me 3. So this ends up with a solution in relatively few steps. It's a lot cleaner than trying to go through substitution or elimination like you did in grade 10, but kind of with more equations and more variables to solve for and more to keep track of. So here we get a solution: x equals negative 2, y equals 3, and z equals negative 5. So that's the end of the day 8. On our day 9 and 10 lesson, we will be extending this and using this as in the application questions of where we're actually solving and talking about how 3 planes can intersect.